Yes, we are live. So we can continue last week's what was it? The discovery protocol discussion. So I made some changes to it, and basically I also added the drone to the network. But then I had to write a lot of code again for and repetitive. So what I did was consolidate the repetitive parts into a single repo and made the robots interfaces as pluggable. So you could basically write some glue code with the robots you have for the affordances the robot has, expose it via some metadata with the glue code. And then, like when you start the server will should pick those affordances out. Maybe I'll share the screen. Is it visible? My screen. Yeah, so this is what we had last week. So
Yeah.
the green part was a little really crude way to add robots and remove robots. So I had this separate. So I had to make this fast MCP servers individually for each robot, and the discovery was also not exposed as a single or an MCP tool. So you had to manually run or type the Python script to find the robots, and then like each robot had this like its own HTTP endpoint. So what I did was consolidate all the green parts into a single Python program, and then I also made a gateway. It's a fast API gateway that you can expose it via ngrok. Uh, what happened here? This is better. So basically, everything and this ngrok tunnel is what you register with the script on the IPFS, and then all these robots can be added to the server with like a plugin. So you add the uh, like the HTTP endpoints and and some metadata into the robots folder. So there is an example called fake rover. So fake rover is similar to the Tumblr HTTP endpoint. So basically, you can simulate the Tumblr now just with this fake rover rover client, and then uh, basically like you could add any kind of robot to this, and then each robot like you could register it to the chain, and each robot, so when this client starts up, it is basically loading the MCP client for each of the robots and exposing it to a certain endpoint on the base ngrok URL. So if it's Tumblr, then it is like /Tumblr/MCP, and then from there the LLM can control the Tumblr. And then I also made a fleet slash fleet slash MCP server, which would basically allow you to discover the robots. And then like basically this would ask the mm, check the blockchain to give all the online robots, and then it will tell you which what are the endpoints and what are the MCP servers or endpoints for it. And the rest is basically like almost the same now. So still not tested it with the real robot, but basically like I wanted to discuss like how could this be improved or some changes, how would this be used. And then I was thinking about like this does not need to be a robot itself. It could be a lot of infrastructure we want to add uh, to the network. So this could be anything, any infrastructure that exposes as an MCP. You could add this as a plugin to this, and then this server, like each of us could like run this server in our homes and then expose like the tools and infrastructure we want to provide. So basically, this is like the core direction I'm taking right now. So the plan is also, so somewhere I saw the plan is like use one of the claw versions to make it a little more agentic, and then provide some more affordances. And then I saw somebody hooking up uh, a 3D printer to a claw. So basically, we could, like, I was planning to add my 3D printer and do expose some MCP via that. Like, I don't know what I'm going to do with that, but yeah, that is the plan right now.
Could we, um, just a quick question.
Yep.
Could we try to hack like a Roomba or something like that? So like we could potentially
Yeah.
I think it would be interesting to
Yeah.
have a robot in someone else's house and like in a trusted network like ours, right? And like try to activate someone else's robot or something like that.
Yeah. So this is like, so the steps, so this could be any robot, right? So basically, this is the architecture. And then, like, one of the plan was, I was thinking about it yesterday, that like I could buy a Roomba like robot. So some of these robots come with the Matter. Uh, so Matter is a protocol, like a home assistant, home automation protocol. So it's you can control it via like Siri or Google or Amazon Alexa. And then Matter is like an open source protocol. And many of these Roombas or like Roomba clones come with Matter protocol. So one of my to-do list is like integrate the Matter protocol into this. Basically, then you can uh, like control a lot of the home stuff with this infrastructure. So
Yeah,
that is like on the
I
future. Yeah.
I think light bulbs as well might be fun. So like if we start thinking about the Internet of Things, there's a long list of interconnected things which are quote unquote discoverable, right? So this type of interface um could be quite interesting, not just for like the definition of a robot that moves, but also like basically anything that turns on and off, right?
Yeah. So, and then that is what the discussion about the space infra led to. I think, like, like what should Venkat was having this question, like what should not, we should not put inside this box. Like this could box could be just anything, but like, what are the things we would like to put it in? And then like, then we had found this paper. Where is this? And then we found this paper about industrializing space. This was the paper, rapid bootstrapping of space industry, and so this has a lot of infrastructure, and like a lot of this could be like automated infrastructure. And then I started thinking like maybe this is the minimum we would like, or the stuff here we would like to add to the robot fleet box. So this is like chemical plants, and then some metal and manufacturing stuff, and then there is something related to, I think, 3D printers too. From that is where I got the idea of adding my 3D printer to the network. So yeah,
I think the
this is
only other open question that I think would be interesting to explore is like how do you know basically what's a real robot versus not? I feel like there's some sort of like verification or registration or credibility or something like that. Not for right now, just something that comes top of mind. Like if you have a network of robots, how do you know like you're gonna buy into a robot that will actually do the thing that you send the signal to?
so like during the registration of this, so there is some metadata added to the IPFS. So right now, the metadata is basically you could add some class. There is some classification metadata that you add to the 8004 registry, And right now it's like I have kept it as a robot, but there are some other categories too. So basically, like, we could use some of those categories to classify the things that are added to the network. So that is handled kind of with 8004. And then it also has some reputation registry, like people could vote if it's a robot or a good robot or a good light or good IoT stuff.
Yeah, yeah. Like it's a yeah, that's kind of what I was thinking. Like, what is a quote unquote good robot? And that's kind of it's an interesting question. Like you don't want a bad robot, and you also don't want a fake robot, right? And it's
Yeah.
kind of interesting to ask that question of like what makes a good real robot that you can add to the network.
I don't think you necessarily want to limit to quote unquote real robots. An idea Mayer had, I think, very early in this project was the idea of like basically synthetic virtual robots, like assemble capabilities from different available entities and then treat them as a unit. And then if you want something that requires multiple things to come together and form like a synthetic entity, that should also be possible, whether it's
Y-
just temporary or not. So it's more,
Yeah, so
yeah.
yeah, sorry, I didn't mean fake and real as in like physical and non-physical. I meant as in like if you pay for a service, the service gets executed
Yeah,
versus you get robbed.
Oh,
I got that. I got that. But I'm saying that you can't actually disambiguate that situation easily because under 8004 and similar schemes, the way you check for like reliability in execution is through some mix of like reputational metrics and the ability to like do test driven contracting, right? It's like, all right, if you claim, we were talking about this last time, if you claim you're a drone that can take photos from a certain altitude, go take a test picture right now. It's like
Yeah,
holding a
yeah,
newspaper in a kidnap tank. So that's test driven verification, that's like real proof.
yeah,
And then social proof, but neither is perfect. Social proof runs into a liquidity problem where either the robot simply doesn't have enough reputation, or in the case of like a fully synthesized robot that's just being like just in time uh, orchestrated right now, it comes into existence only for that one task. So then you have to compute reputation from the components or something. And the
yeah.
other way of like giving the robot tests, um, I think that will have serious limitations too. Like some capabilities you can test, other things may just not be testable. So there's a fundamental
Yeah.
here.
It feels so when Amazon like the products have reviews, but the vendors also have reviews. Um, and this when you say that, this reminds me of like uh this reminds me of kind of like the reputation of the register, not necessarily the robot or service itself.
I think there's a basic issue here that if you want a robot to do things that it's done before, let's say boring stuff, so you can talk about reputation and so on. But if you want a robot to do things it hasn't done before, then you need a mechanism for verifying that it can do it. And a lot of these reputational things won't help with telling you if the robot can do something it's never done before. So
Yeah.
are we focusing on the first type? Let's call it standard activities. Or are we looking also at the second type, which is robots will be asked to do things they've never done before?
I think, and just a final reaction, I think all this gets solved by robots being used. So I don't think we need to worry too much about reputation because kind of like the market will does solve for itself at some level. Um, yeah, kind of like how meme coins are not like registered and yeah, it's a shit show, but like there is a trading market. Like the trading market exists.
Yeah, but we're not talking about a trading market. We're talking about people using robots. I want to have pictures taken of my roof. No Tumblr's ever done that before. I can guarantee. So, and let's say there's only Tumblr's on the network? How do I find one that is able to take pictures from my roof? Okay. Or you can say, no, if nobody's done it, nobody's done it. Okay. You can only hire people, robots, to
Yeah,
go
you
through.
you could you could do it backwards where you could broadcast your intent and robots could bid
They bid.
for completing your intent, right?
They do, but they can't
So,
do it.
oh, I see what you mean. Yeah, I'm not sure. But is this really a problem that we need to worry about or that you guys want to worry about right now versus just like testing and prod?
Well, I'm asking exactly that question. I'm asking, are we interested in selling standard provable services, and building a system for that? Or are we interested in the more difficult problem of services that are not standard and are not part of your reputation? You go to a bank and ask for a pizza. Anuraj, what do you think?
If it's a trusted network, then it's always known, right? What everybody is like. If it's within, it's like the open market. That is where some level of like trust-based thing could be done. But then on Amazon, you have these fake comments, right? Like spam comments, like people are like praising
Hmm.
or hiring people to comment nicely about the product, and then when you actually get the product, it's not that good. But and the bad comments are basically buried down under the good comments. So all those dynamics come into play if it's just purely reputation based.
So how else? I want to say again, one of the problems is that robots interact with the real world, and the users of the robots might not be experts. So maybe I took an extreme example of, can my tumbler fly above my roof and take pictures of it? Okay, obviously it can't do it, but can somebody rent out a tumbler that will go in my yard? And as you know, there's cats. Maybe they eat tumblers or jump on them, in order to have fun balancing. So it's not just, do I trust you, which is a regular question, but if we want, it's how do we talk about trust in activities where we don't actually know ahead of time if they can be done. It might be a vetting process of some sort, but even if you pass it, it's not going to be 100%. Just because Anuraj's robot is capable of going around his yard doesn't mean it can go around my yard.
So sorry, Mayor, I do understand. I do agree with you, but I don't understand one thing is that going to your backyard, what is the problem here? It's going from A to B, right? So if a robot can go to A from A to B, it's likely to be able to do what you're asking, except if there are on the way some issues. Okay, like for example, a door that requires a key. Okay, is it what you mean by not being able
I
to do
think
it
I think you're oversimplifying the physical world.
on purpose?
No, let me give you an example that doesn't have to do with my yard, but has to do with a simple going from A to B. So we have a lawnmower, and it's mowing my lawn, and then somebody goes on the network and says, "Can the lawnmower come over and mow my lawn?" And guess what? It's only 100 meters away from my house. Can the robot move 100 meters from point A to point B? Absolutely, it can do that.
Mhm.
But as the robot actually tries to move, it turns out there's some construction on the sidewalk, and the robot doesn't know how to go around construction. That's it. It failed because the real world is
No, okay, but
complicated.
is it a problem? I mean, in the sense
Yeah,
that we have a protocol where that robot claims it can do it, so it will
yeah,
bid for it. Okay,
Yeah.
and it will try to do it, but it will be unable to prove it did it, so it won't get paid. Okay.
Usually,
Isn't it the problem? Is it the problem?
absolutely, because we don't build the network in order to protect the money of the people paying for it. We build the network so people can get services. But if these services will often not happen, then we failed, even if you didn't pay for it. I mean, people
What if
want effectively a
That
TCP
sounds
network.
like an edge case. That sounds important, but still an edge case, right?
And that's my question. Is it
And
really
it's
an
not.
edge
It
case?
doesn't get out of the protocol. I mean, it seems like the protocol covers that situation. Okay? That's
But I
okay.
don't think
The contract is not fulfilled, so
so.
we
So,
backtrack the contract and we don't pay, basically.
so that was my question. Are we going to talk only
Okay.
about activities which are standard and done and believable, or can we talk about other things? And I'm pointing out that the users, they don't know what can actually be done, because it might turn out that there is no sidewalk between my house and somebody else's house who wants to get um, lawnmower services.
So this is a solved problem in the human world. What you would do
Right.
is have estimation and learning activities. Like when you ask a contractor, "Can you come do something?" They will say, "Hey, I don't know. I'll have to come and give you an estimate." Then they discover what they need to know in order to figure out whether or not they can do the job. So you kind of need that kind of protocol as well. So this is, I think, an enrichment. What you need, and this is where I think interesting things will go wrong with LLMs, because they will have a way of like bullshitting that they can do stuff whether or not they can. So we need like a mechanism by which it knows its capability, and when it doesn't know, it says it doesn't know and says, I'm going to bid on this job, and because I've not done this before or I don't know, I'm going to bid like a estimated amount, but then included in the estimate is $5 for actually going and checking out this, whether there's a sidewalk, and if not, I will cancel the contract and refund your money, something like that, right? So this is um, a
Yes
solved
and no.
problem, just not been solved in this context.
Yes and no. Let me explain. Anuraj once has a network with three components. Component number one is a tumbler. Component number two is a drone. And component number three is a 3D printer. Now, with a 3D printer, anything you ask it to do, it says, here are my specifications. This is what I know how to do. With a drone, the world the drone interacts with is relatively simple. Okay, it has to take off, electric wires, trees, wind, and rain. Okay, so it's more likely to be able to let me come and give you an estimate and see, the wind is not too strong. But what I'm asking is, when we talk about robots that interact with the physical world, is the world structured enough that we should be able to expect that most interesting activities can be carried out or predicted or even given an estimate? Okay, imagine the lawnmower robot wants to give an estimate to do my neighbor's lawn. Is that even a task that a robot can do? Human, sure. Human looks over the fence and says, yeah, I can do that.
I think robots can too, like they can do it now. If you just add a camera to the lawnmower and connect it to cloud code, it'll upload that photograph and give you an estimate. It may not be great, it may not detect that there's an NP complete problem involved, but it'll do something. And I have a feeling I'm optimistic about this. Like in a very general sense, because it's trained on human data, it includes human sort of like estimation heuristics and stuff. And like so far, my experiences with Cloud Code have been, even when the problem is like full of traps like that, like you might accidentally start solving traveling salesman or something, it tends to have good heuristic instincts. It sets things up in a reasonable way, estimates, and goes about it. So yes, I would guess that this is actually doable for commands that stay within the reasonable space of human experience. Now, if you put these robots on Mars and you have like a completely abstract AI system that's coming up with arbitrary tasks based on no storehouse of experience like human activities on Earth, then all bets are off, right? But that's fair. Like if you don't know anything about the environment, then yes, you should expect to fail a lot and and be wrong a lot. But if you're operating in a domain where there's a lot of stored experience, you can expect to be reasonably right a lot of the time. So lawn mowing, I would have high confidence AI can pull it off. Random geology on Mars, I don't know. Maybe Mars geology is not similar enough to Earth geology for that training data to be helpful.
Why do you think lawn mowing can be done? The lawnmower has to get from my house to his house. That's not a trivial task. Delivery robots today are, at the edge of their capabilities dealing with moving from one place to another. That's one of the reasons to use drones. It's
Yeah,
simpler.
I'm not
You
saying it's
can't get
trivial,
stuck on the way.
I'm not saying it's trivial. I'm saying it's doable. It's been done. There's training data for it. Humans have done it.
Okay.
There's like software assistance. So there's lots of it's not an easy problem, but it's 80% a solved problem. It's just a grind. So I think I'm not sure what you're getting at here. It's a hard problem. Sometimes it'll get solved, sometimes it won't. When it won't, contracts fail, somebody pays a fine or penalty, we move on. You seem to be suggesting there's a fundamental bottleneck here.
I have some things to say just to build on this example. I have a neighbor who has a lawn mowing robot. This is a real situation for me. But I was talking to him about his robot, and it has a constraint, which is that it can only work within, I think, about 100 meters of the antenna on his house. So when he installed it, he had to climb up and install I don't know if it was Wi-Fi or a different frequency, but he had to put an antenna on his house, and he had to locate some sort of transmitter or something at the end of this antenna. And the robot can only get so far away from this antenna before it just stops working. So if I was going to ask this robot to mow my lawn, it would not be able to do that because it's too far away from the antenna. And so I would like to know that in advance. If I was trying to figure out how to use a robot on the network, I would like to have some idea, what is this robot capable of? Like if I'm trying to assemble a super robot from components or something, I would like to know, okay, what can each thing do? And what can't it do? What are its limits and constraints? And I would also just like to say I have been talking to human contractors for my house renovation, and that's quite an experience. And they are different from each other. There's some who you'll talk to who will have a certain expertise, and they're like, I want to stay in my lane. I just want to do this one type of thing for you. I'm not interested in anything else. And there's others that will be like, oh, well, let me know if you have other odd jobs that you want to take care of during this time. I might be able to do them for you while I'm here. And people kind of in between. I also think when I have been getting estimates from contractors, there's things that I look for to see what it will be like to work with them. So things like how responsive are they? How well do they answer my questions? Are their answers accurate? And I also try to get a feel for their mindset, which that might be a little trickier with a robot, especially if it's like modern LLMs. But like, for example, when I was talking to tile contractors about our house, one of them took out a laser level and actually measured and showed me what the slope of my floor was, because the slope of my floor was not sloping towards the drain. So we wanted to fix that for the floor. And I figured out what the slope was of the house. And we actually took a laser and a tape measure and got a good sense of it. And then we talked to another tile person who just kind of eyeballed it, and he got it completely wrong about which way the floor was sloping. And that made an impression on me, both of those experiences. Like, I ended up going with the first guy who actually was accurate about what our floor was like and demonstrated it to me.
This is what I mean by it's a solved problem. So you did basically A/B testing, found out one was more reliable. And if you were to go back on Yelp, you would probably give the first guy a good rating and the second one a bad one. Same thing with your neighbor's robot. It has this constraint around the Wi-Fi access point. that may or may not be documented. If it's documented, if you query its API, it'll say, I have a constraint of a geofence of 150 meters around or whatever. And if it's not documented, it'll try and fail, and then you will give it a thumbs down. So that none of this sounds like a mysterious fundamental science problem to me. This sounds like a whole bunch of like annoying engineering solved problems that are annoying to solve but are solvable. But now we have Cloud Code, and it does this sort of thing. Like literally, I think I've been discovering what Anuraj discovered 3-4 weeks ago, that it's actually good at this kind of like very grinder reasoning and works through and comes up with reasonable answers. So I think I bet if I fired up Cloud Code right now and said, write me a simulator of a lawnmower that may be rented out to neighbors and include this constraint and so forth, even if I don't say that, there's a good chance it'll actually think of it and put it in itself. It's so I think we have to distinguish between true fundamental research problems, as in it's a fundamental mystery how it might get solved, versus things that we already have solved with AI and robots, versus things that we kind of know how to solve with humans and like pre-AI technologies, and that just need translating to the AI modern robots kind of paradigm. So there's like classes of problems we have to be aware of. And Mayor, I think you're in the second class, as in it's not a mystery, but it's not a solved AI robotics problem, but it is a fundamentally solved human problem. And my bet is it'll be far easier than we think now to actually port it to AI solving it.
I would like to pick up on something that Ellen said, which was very interesting. She says, I get a sense of who the contractors are, but it's probably going to be more difficult to do with robots since they're all working through LLMs. So if we have humans ordering the work, the humans are going to have to trust the robots that they can do it. And if all the robots sound like ChatGPT, how exactly, or even without that, it's a more general question, how do you expose, let's call it the reliability of the robot in the type of way Ellen is talking about?
You actually just answered your question. You said Chat GPT, and I have been playing with Claude lately, like the chat interface, not the code interface.
Yeah.
And they have very different personalities. And I actually had the same experience. Like, I'm going to trust Chat GPT to do certain kinds of like grindery things. I'm going to trust Claude to do certain other types of things. Even these foundation models don't actually have the identical personality. Like, these differences in training recipes have created differences in behavior and how you trust them. And I think this will just become extremely diverse, and we will have this experience with robots and AIs too. They will not all sound the same. So
yeah, but there's no connection between what the AI says and what the robot can do. We already have these.
I think you're wrong. I think you're wrong. I'm already seeing that with LLMs at the text level. I am seeing that you can judge what ChatGPT versus Claude will do better or
worse. You didn't understand me.
Yeah.
You didn't understand me. We have two robots. One of them is using ChatGPT and one of them is using Claude. Okay? But there's no connection between the robot, what it can actually do, and what ChatGPT or Claude says it can do.
I think you misunderstood me now. I was using Claude and ChatGPT as an example up to the text level. I'm saying the same phenomenon will happen with whatever local robotic RL models are running on the robots. You will find that because of the unique training histories and embodiments, they will actually have the same kind of like personality differences, which will actually be reliable indicators. Like, there will be a bullshitter robot that always claims to do more than it can. And then you'll find that out soon enough. It'll always confidently say, yes, I can mow that lawn. And then it'll fail 90% of the time. So this is what I'm suspecting. Just because of the way the technology works, the personality does come through, and it does seem to correlate with what they do or don't do well. But I think this is like a very long bunny trail. Anuraj seems to have some other stuff pulled up here. Should probably give him back the...
We'll pick up this bunny later. Easter is coming up soon anyways.
So this is the 8004 specification, and there is also a validation registry. Basically, you could stake something and then like basically have some reputation against that. I think like what was that company that does restaking? I forgot the name.
Eigenlayer.
Yes. So we could include something from there, and like for the robots themselves, and have some sort of validation. It's this mainly comes into picture when there is a dispute, right? Otherwise, everything moves smoothly. Like, then how do you resolve the disputes? That's the contention, right?
Yeah, eigenlayer would actually be appropriate, but it might be overkill. It's for like much larger. It's for like a couple of levels of abstraction higher. For like entire infrastructures, whether or not they're reliable, and if people disagree, there's a fork of the like eigen token and stuff like that. It would be nice to do that at the micro level with single objects. Rafa was posting something about staking.
Okay. L- Rafa, do you want to say the things you are typing, or should I read it out? Okay, like basically, Rafa is saying that it would be mostly agents interacting with each other, and then we are primarily worrying about human interaction with the robots. But like, I don't know how much true that is, because like currently, like we are mostly teleoperating the robot, so it's mostly, and then there is a human trust layer in between. Okay, he's having some mic problems. Yeah, so
I think
and
Eric was
then
also typing something about validation problems in the same thread. Eric, you have something you want to add here?
On the validation of what? Sorry.
No, you posted there's a problem of verification here, reputation, blah blah blah. Yeah, or was that?
Sorry, just setting the context.
it
But the
was
thing
about
is
the
that
validators. Yeah.
yes, I mean what Rafa is suggesting here, to have basically a BOM, okay, a detailed BOM of the robot, okay. But the BOM belongs to the robot owner most likely, okay. So it doesn't address any issue of reputation here. It can help. It's extra data that we can use to evaluate that the task has been done or not, okay, or whether a task can be done or not. Okay? But still, it's like what Anuraj was just showing here. This yes, that where in this protocol how we declare our skills. Okay, we support MCP, we support email, we support this and that. Okay, this is what we declare. Whether it's true or not, we can just evaluate over time using reputation score. Okay, a BOM is a more detailed version of that. So the problem remains that it may just be blocks, right? Okay. So that's what I meant with my post on the verification.
These are the like features right now in the 8004 reputation registry. Basically, quality, endpoint, reachable or not, owner, uptime, success rate, response time, cumulative revenues, and yield. I don't know what this is, but or these are
Yield
just
actually sounds
examples.
like the percent success or something like that. So it might actually be a good indicator of real time or a real capability as opposed to reputation, or maybe not. Wait, what are the things on the left column of the yield? Tr- Trading yield. Okay, no, that sounds actually like a financial yield metric.
Yeah,
Is it? You see, for human beings, basically, I don't know. When I was a beginning engineer or beginning scientist, I have nothing to show. Okay, maybe some toys I built and stuff like that. Okay, so we need to bootstrap somewhere, right? The reputation. And whether it's an H score for scientists or something like that. Okay, but how do we address that basically as human beings? We go to uh, some training sessions, okay, to get a certification as a AWS engineer, whatever, right? Okay. Isn't it something that's missing here, okay, for this protocol. The protocol is about how to flexibly, maintain this reputation registry, right? Okay, but how do we bootstrap basically? Should we have something like a gym for robotics, basically?
We have robotics contests, like in the early robotic soccer years. That's how the teams and individual robot designs built up their reputation, by going into contests, which are not like real world jobs. But actually, this is actually a good example, because my postdoc advisor, who ran the Cornell Robo Soccer team, because of the reputation his group built up with robotic soccer, that's why he was able to co-found Kiva, and then Kiva became the robotics vendor for Amazon warehouse, right? So this is actually a literal example. So you could think of the robots as being unproven, and then kind of like showing off their skills and building reputation in like a sporting environment, and then turning that to a job. So that might actually be how this works out. People build robots, they kind of like enter it into contest like scenarios to gain points, and once you have enough, people start trusting you. So yeah, you can bid for real jobs.
But that's team-wise or robot-wise. But perhaps there is need to extend that idea to skill-wise. That if a robot claims that they can they can do lawn mowing at the mayor's place, what needs to be checked that to be sure that this robot can do it, okay? And that can be, okay, does this robot have the credential, the permission to access the robot in the first in the loan in the first place, for example, okay? Yeah,
But I think that's for well understood tasks. I think that's getting to the point that I think Meyer was saying earlier. Like, we know how to mow lawns. We might kind of know. It might be a little bit harder to figure out what the criteria is for mowing a lawn than with the, I don't know, with the tumbler than the drone or whatever. But like, what if you're trying to do something that you haven't done before? Then you can't look up someone's certification of how well they did it, or whatever.
But that's a great point. But I wonder how we deal with that already with certifications. I mean, we can be let's say an AWS certified engineer and start a job at a company that is using Google Cloud, basically, right?
I think Ellen is asking an even harder version of that question, because when you assume an AWS certification, that means somebody already has learned how to do it and has created a certification program that others can then take, right? So in that sense, it's an already solved problem by somebody else. But I think the way to solve the problem Ellen is talking about, which is a fundamentally new problem nobody has solved, if you look at how defense and space type agencies actually solve that, it's by offering basically fly off type contracts, right? So you want to go to the moon and establish a base there. Well, you put out a big call for proposals. SpaceX and Blue Origin apply. They are given opportunities to prove themselves, but fundamentally it's new. They may fail. Same thing with this is the way it used to be done with the Air Force, which is they want to build a new type of fighter jet. They will put out a contract. Lockheed and Boeing will bid for it. There will be an X versus 5 fly off. The winner will get the contract and build it. So lots of risk, but that's kind of how you certify things that have been never done before. You do it through open competition against test tasks. Same thing with self-driving cars. You had the DARPA self-driving challenge, which was not a certification, but it was a 150-mile course, and it was like, can you finish the race at all? No, it was not like a rule-based sport like soccer, but it was more like an open-ended grand challenge, right? So I think that's how you would do it for completely new tasks where you don't have precedents and ways to do certifications.
Okay, but what if you don't have the budget of NASA or DARPA or whatever? What if my 4-year-old wants to see if he can put his, I don't know, piece of origami on the roof or something? But the robot is not actually designed necessarily for that, but we want to make use of it in a way it's not really hasn't. It's like, I don't know, with a drug, an off-label use of a drug or something.
Oh, at some point you will go from figuring out plans based on precedents and like patterns you've seen in the past to first principles reasoning, right? And this is more a GoFi type problem than deep learning type problem. Like at some point you might say, there is nothing in my training data that suggests how to like take an origami crane to the roof. I might have like close patterns like lifting objects or whatever, but maybe at that point it'll instead invoke like a strips planner and just logically solve the problem. It's like, this is how you grip an object, this is how you lift it, this is how you drop it, right? That's how it used to be done in classical AI planning before ML. So that's a way to like pose and solve open-ended problems with just like reasoning them through. Yeah, and that has its own computational complexity and success failure rate. Like you might end up posing a problem that fundamentally has no planned solution, and you have to like change the constraints of the problem. Like, if the origami crane is too heavy for the drone, then maybe the answer is get a more powerful drone, right?
Mhm.
So
but do we need to represent, like, leave space for this and whatever Anuraj is doing for first principles reasoning, or for combining, I don't know, a drone with another thing that also has like two drones to pick it up if it's too heavy? Or like, is this relevant to what we're doing now?
Yeah, so we have been thinking about like composable robots. So like two tumblers could join together and do some work, or a tumbler and a robotic arm could uh, join together to do some more work.
this was actually one of the projects I did at Xerox, and I have a patent on this. Actually, it's we had a scheme called recursive auctions. So you have a mass of agents with a bunch of different skills that can. This was the original domain was graphic designers who can like put designs together for print projects, and the way we did it was top level person puts out a contract for something like design and print 500 copies of a brochure that involves like graphic design, printing, marketing, copy, all those various skills, right? And somebody thinks that they have some but not all of the skills to pull the job off, so they put in a bid and then they subcontract it out, and then you have like a hierarchy of auctions, and if all the auctions close, you have a complete bid and you submit it and you might win. So we created software for that. So yes, I think that is solvable, but there's a minimum scale and volume and like market liquidity and things like that where it makes sense to do things like that. uh, Below that it becomes like overkill, I would say. Yeah, so we kind of need a richer range of examples to think about. Like lawn mowing is good for thinking about some things. Maybe that space paper has other examples of what is reachable within what you have and what you can print and what robots can reproduce. But yeah, I think all this is within range, but it's like miles away. So this is a stub or starting point from which that kind of capability can grow. I think my vibe coding experiments that I was posting about earlier this week might actually be relevant here. The trapeze blocks thing, it looks like assembly with like a crane like set of multiple agents on warehouse type thing, but we could adapt it to something like, all right, you have a moon base where certain things need to be assembled together, and that kind of approach could work.
Yeah, I was just asking Claude, like, what are the automated infrastructure elements that are there in the paper? So it gave me all these basic classification. So basically, a chemical plant, and then a manufacturing plant, a power plant, and then robots to do all this stuff. Yeah, that's why I wanted to add my 3D printer to the network.
Mhm.
And you'd probably want to add a bunch of software agents as well, because like take this example of classical planning. If at some point the agents decide that to actually solve a problem they need software that can do logical planning, then they would like subcontract that job to the software agent that does strips planning.
Yeah, so basically one of the claw versions could be used for that. There are like several versions of it right now. OpenClaw is the most used one.
My suspicion is that the ratio of physical agents, in some sense, to software agents is going to be 1:100 or 1:1000. Like there'll be, for every like robot running around on the moon, there will be 1,000 software agents sitting around that can be pulled in to do any specific thing.
Anurag, I also wanted to ask: does it matter what type of web server you're using, like whether it's Apache or Nginx, or is that like in your diagram? I didn't really see.
So right now everything is done in Python. Well, that's what I am most comfortable with. So basically, like when I'm vibe coding all of this, I need to steer, and then Python helps me like keep the context in head. Like if I would try to write this in Rust, then yeah, I could like completely trust cloud, but then basically I want to see inside, like have a feel of the code. That's why I do it in Python. But this is just like the blocks, high level blocks, and then some of the, so you all, it would be easier to do this in TypeScript because all these um, the libraries I'm using, they either have Python or TypeScript versions.
That
So
wasn't,
yeah.
but I meant for your web server, because you are interacting with the internet, right? So you're gonna have to
Yeah.
install like.
What are you running right now on the yakrover.com domain? Like
This
you're using
this
fast
blue
API
part,
to do. Hmm?
this blue part. So this blue part and green part is what we need to combine. It's not there yet. So because like these are two separate things now. But this blue plus green part is what we would ideally want to be running on the yakrover.com.
I think this doesn't have the details. Alan.
So basically, like what is there is like the front end is done in React, right? And then like I have a backend to manage the robot sessions, payments, and wallets. And then basically right now it just interacts with the registered robots with HTTP, and that is already known, and I have hard coded it.
No,
And
I think
then
Ellen was asking about what's the like literal web server you use. Is it Nginx or Apache?
it's Caddy.
Addy. What is that? I haven't heard of
Uh,
that.
Caddy is like I don't know what it runs behind, but it does the HTTPS TLS handshakes automatically, and it renews the certificates automatically. So I serve it with Caddy, and then like this, the React gets compiled into a single page application, and that is what it serves on the web browser. And then this web browser knows the backend URL because they are running on the same server, right? So it's like a separated stuff. So the backend is basically running the whole logic, and then multiple front ends can connect to it. And backend is basically behind a firewall. So basically, like right now, I serve the React with a software called Caddy. Uh, I don't know underneath what it does, and then it like basically making HTTP calling the API endpoints on the backend, and the backend calls the HTTP on the robot. I don't know if it was clear. So, and then like this fast API backend is a separate stuff, and than the MCP 8004. So this is also a fast API gateway that loads multiple fast MCP servers. So what we need to do is this combine this fast API backend I have for X402 payments with this MCP loaders for the robots. Then we have like a complete system for payments and registry and MCP and discovery. Yeah. I don't know what exactly I'm building, but I'm keep 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 on building
That's
whatever.
good. That's good. Not bad.
And the code is there on this YaRG 0 for MCP. If you go there, this is the flow, basically how you would use it with the LLM. So either you find the uh, Tumblr with the first time with the Python script, or like you already know the domain of the fleet, and once you know the fleet URL, you can basically find all the robots that are on chain with the LLM. So if somebody in the US wants to, they run first this, either they discover, and then they will know the fleet MCP server. So and then you add that MCP server to your local LLM, and then you should be able to interact with it in natural language. Yeah. Any more comments on what I should add, remove?
No.
We are on top of the hour. And yeah, if you want to run this yourself, just let me know. I can just post it in
Thanks.
Discord.
It would be good to see even a simple demo next time, because I'm having a hard time appreciating how all this block diagram stuff works together.
Yeah, this is like a slightly higher level, and then I can demo the green part, how it's done. The blue part is not still integrated to the green part. So this is, we want a single green box here instead of the blue one. Maybe in the next few weeks, I would have something. Yeah.
Did you show at some point some kind of UML interaction diagrams? Because perhaps that could help to see how the
Okay.
different paths go together. How you can generate them as well, of course. Huh?
Yeah, it was. Let me.
Maybe it'd be more interesting to see a dashboard that shows us, how each one of these boxes, what it's doing at any given time when we see this demo.
So this is kind of what happens in a UML language.
Mm-hmm.
So if first you register the agent on the IPFS, so basically after that you store the JSON agent card on IPFS, and then you find that that metadata JSON is also like stored on like you can discover it on the blockchain, and from there you get the MCP endpoint, and then from like local language like LLM client, you can just connect to the MCP server and then ask the MCP server to interact with the robot. So basically from MCP server it's just like HTTP calls, and from LLM it's like a MCP call. This is like the payment part. Payment is basically there is like a facilitator in between that verifies the payment once you have done, and then tells the LLM, okay, or not the LLM, or the front end, the payment has been done, and then it provides the access. This is a little separate part from how the MCP connects. But like I can demo the LLM calls, how I control the robots with an LLM next time. And then I also have like a text to speech on my phone, and then I can, and then like a SSH to the MCP server I'm running, and then run Cloud Core there, and basically I can talk on my phone and control my robots. So that is what I have right now. And there are certain desktop versions of that too. Like there is a free desktop software called Vocal, which you could basically use text to speech on your desktop computer and then talk to your robots. Yeah, I can try to set that up next time. Let's see. We are 4 minutes past, so maybe we meet next time, right?
Mm-hmm.
Okay.
Thanks.
Thank you. Bye.
Great progress.